Let's begin with some characteristics of the hybrid. Reading across that chart there, we can see characteristics, and then they divided into mild, medium, full, and plug-in type hybrids. And then the characteristics are important. The auto shutdown, that's the start-stop function. The regenerative braking, the motor generator turning into a generator during deceleration or braking in order to recharge the high voltage battery pack. Traction motor assist means that the electric motor helps the internal combustion engine to propel the vehicle forward. Electric motor only, meaning that the ICE can be turned off and the electric motor will drive the vehicle. And then, of course, minimum 10 miles on electric only. And you can see, starting on the right-hand side, the full and the plug-in have the more yes. They have the more characteristics or the more features in the hybrid. In fact, plug-ins, yes, all the way down. Full is yes all the way till it gets to a minimum of 10 miles driving. It's the medium and the mild that doesn't do all the things you want from your hybrid. The small Hondas and stuff. You know, yeah, they shut down the ICE at stop signs in order to save fuel and, of course, emissions. They have regenerative braking on a medium, but that means all the smaller ones don't have it because the milds don't have it. Traction motor assist, yeah, but in some cases it's limited. So it's very important for you to learn these characteristics, because if a customer came in and said, you know what, my hybrid never operates in electric only, the ICE is always running, and you look over there and it's a mild or a medium type hybrid, it's not even supposed to. So understanding these characteristics along with the following terminology is very important. So mild, weak, micro, medium. These type of systems provide electric assist to the ICE. They do not propel the vehicle by themselves. Only the strong hybrids provide electric drive or ICE drive or electric assist, meaning that the internal combustion engine can propel the vehicle, the electric can propel the vehicle, or they can both work together to propel the vehicle. Now, series hybrid is another whole new language. Let's just step back here. We're talking about mild, weak, micro, strong, mediums. Here, we're going to add a new set of terminologies. And we're going to talk about how this hybrid is built. Series hybrid, the ICE isn't connected to the transmission or the transaxle. It's not considered a mainstream design technology, and that's due to the required number of batteries and the battery technology. The Chevy Bolt, for example, is going to be a series type hybrid. Now, the ICE isn't connected to the transmission or transaxle, and that means that the ICE operates the generator, and the generator is what adds propulsion to the vehicle. Now, this is a series type hybrid drawing. You can see that we have the ICE over there. And of course, we have the generator and the motor. That can be one unit combined, or it can be two separate operations there. We don't even know. They haven't built the Volt yet, and we haven't had an opportunity to look at one yet. But when you look at this, you can see that the ICE on the far left isn't connected to the drive axle. It isn't connected to the actual drive axles or the drive wheels. And of course, we're going to have battery packs with that and a computer to control that. Now, we're going to have all the other things that we've talked about, the engine controllers for OBD2, the AC controllers, the accessory power module, the ABS, all that's going to be on the CAN bus with the motor control module. So let's talk about a parallel type hybrid. The ICE is connected to the generator and the transmission or the transaxle. This is considered a strong hybrid, a two modes type hybrid. It is considered the mainstream design strategy for the high profile automotive manufacturers like Toyota, Nissan, Ford, GM, Chrysler. The parallel design permits lower total system mass. You know, they don't need all those big components. Everything can be smaller. And it provides a smaller package, and that smaller package is going to provide advantages over the series type hybrid. Now, the parallel design is characterized by an engine system that is connected directly to the electric propulsion and the drive system. Both the engine and electric propulsion can provide drive for the vehicle. So here's our parallel hybrid. Now look at the ICE there where the arrow's pointing, and you can see that we have a tube connected through a transmission or a power splitter or a planetary gear system into the motor, generator, inverter, controller setup there. Right there, in the middle there, where the red arrow's going up and the black arrow's going down. That is our motor generator there. And then, of course, we have that black tube going to the final drive, the drive wheels. They don't have to all be rear-wheel drives. But what we're saying is that this system is connected directly to the final drive, motor generator, and ICE. It's all together. It's all connected together. It's going to have a battery pack. It's going to have all the controllers just like the series hybrid, and those controllers are going to help the hybrid controller operate this vehicle. So the series parallel is next, and it can use the electric drive mode only. That means it's going to operate in series, like the series, electric only. It can combine both the electric drive with the ICE, and that would be a parallel type system. We really don't have these in the automotive industry, but they are used in other industries like construction equipment and, of course, buses and trucks and things. Now, here's our series parallel hybrid, and since they're not involved in the automotive market, but you may be a fleet and you're saying, hey, I work on construction and heavy trucks, we're going to show it to you here. We have the ICE here, and then of course we're going to have the motor generator unit. And in the motor generator unit, what's going to make this a series parallel is a planetary carrier, a sun gear setup that says, hey, I can allow the ICE to drive this vehicle. I can allow the motor generator, the electric, to drive this vehicle. I can have them both function together. And that's how a series hybrid system works. You can see that there's a motor controller module in the gray box there, and of course that's going to be connected to everything else on CAN, just like the series and the parallel hybrids. Now, we talked about the powertrain configuration before. We said it can be between the ICE and the transmission. Well, look at it. In the top left-hand corner there, we have it right like that. The motor generator is between the ICE and the transmission. And on the next one, the motor generator is mounted externally to the transmission, and on the bottom left, the motor generator is belt driven. It's the BAS system. And then the last one is the motor generator is mounted internally into the transmission. Let's look at one manufacturer, the GM configuration for all that. And because they have the different hybrids, we're going to use this manufacturer for no other reason. Over here in the left-hand pink square, it says two-mode hybrid. Now, the Global Hybrid Corporation, the Alpha Hotel Sierra 2, AHS2, is a set of hybrid vehicle technologies jointly developed by GM, Daimler, and Chrysler LLC, and BMW. And two-mode is something that GM uses because they frankly ran out of words to call all these mild, micro, strong, weak hybrids. They just ran out of words, so they made up a new one, two-mode. And that's basically our strong hybrid. Now, it's going to use 2 or 3 sets of planetary gears, so it's going to have a complicated planetary gear set. It's going to have one of those planetary gear sets for the internal combustion engine, the input splitter, and 1 or possibly 2 gear sets for multiplying the power of a pair of electrical motors. Now, General Motors stopped using the AHS2 in 2006, and they're just going to call it the two-mode system. The BAS, or the Belt Alternator Starter vehicle, is a new trend in hybrid vehicles. You can just add it on to any vehicle you want, and it's a cheap way to get a mild type hybrid. This type of system is always referred to as a mild hybrid. If they develop things further, it may turn into a strong hybrid, but right now they're all mild hybrids. The computer system controls an alternator/generator, and that's connected to the engine with a belt, and it turns off the ice for the idle stop function. The electric motor is available to assist on acceleration only. And there's the unit in front of you right there. At the lower left-hand corner, you can see that there's a belt drive to that alternator/generator. And in the drawing at the top right, you can see there's a belt that connects that to the engine. It's a belt alternator starter. And when you want to start the ice, this generator turns, which turns the belt, which turns the ice in order to start it. Now, there's an EFlex system. It's a low voltage, about a 42 volt system, and it does have the start-stop function, the auto ice shutdown. Now, in the right-hand corner there, you can see that we have a unit there. Now, this is exactly what the EFlex system is. If you go to the trouble to look up this exact photograph, you're going to note that is a Honda Civic. That's a Honda unit there. But the GM version looks the same. It has the inverter, and it has the unit that sits between the internal combustion engine and the transmission. And then, of course, we have plug-in vehicles, and that's like the View, and we're going to have the Vote eventually, they say, and that's the EREV, the Extended Range Electric Vehicle type. So you know what? When we say there's no such thing as a GM hybrid, we're serious. That's meaning to say that there's differences, and the differences are so great that you just have to ask, what model are you talking about? Don't tell me you have a GM hybrid in your service bay. Let's talk about a specific model. Now, they're all different, like we said, but you know what? They're all the same. Each hybrid is going to consist of subsystems. The subsystems are going to have functions that are similar, if not identical. We're going to have the internal combustion engine as a subsystem to a hybrid. We're going to have a high voltage battery pack. We're going to have a motor generator unit. We're going to have a DC to AC inverter. We're going to have a DC to DC converter. We're going to have microprocessors which control it all, which talk on the CAN system so they all communicate together. Now, in understanding the hybrid systems, you'll want to view all the videos so we talk about each of the subsystems individually, operation and function. Now, understanding the difference is relevant to diagnostics, as we said. A guy brings in a little Honda and says it never runs on electric only, and that's because it's a micro or a small or a mild type hybrid system. You have to know these things. Knowing and understanding how each configuration operates and works this vehicle, propels this vehicle down the street. What's on, what's off, what can be on together like in a series parallel type system, on a parallel type system. What never happens like on a series system. The ICE engine never operates the drive vehicle. This is what's going to help you direct your diagnostics in the right area.